Okay, the ratio test can be used to determine whether a general series is absolutely convergent and hence convergent. Remember, the absolutely convergent and hence convergent bit comes from the theorem of absolute convergence. So here are the results. So basically, the ratio test, we look at the absolute value of the ratio, as in a division, the ratio of the next term of the sequence over the current term in the sequence. So we evaluate this algebraically. We find the limit as n approaches infinity of the absolute value of the ratio between the next term and the current term. If that value is less than 1, then it tells you that the series from n equals 1 to infinity of the sequence, of the terms in the sequence, is absolutely convergent. If it's greater than 1, it tells you it diverges. If it equals 1, the ratio test tells you it's inconclusive. So to find out if this thing converges or not, you're going to have to use other methods. So here we have an example. We're going to test this an, as in the sequence, equals minus 1 to the power n times n cubed over 3 to the n. We're going to test that for absolute convergence. Now, do note this minus 1 to the power n does indicate an alternating series, but when we use this ratio test, it might be that they wipe out. So if we just go straight into the ratio test, so we are going to find the lim as n approaches infinity of the absolute value of a n plus 1 over a n. So we're going to look at that. So that is going to be the lim as n approaches infinity of the absolute value of, well, a n plus 1 is going to be minus 1 to the power n plus 1, and then it's going to be n plus 1 cubed over 3 to the n plus 1. So minus 1 to the power n plus 1 times n plus 1 cubed over 3 to the n plus 1. So that is your n plus 1 term all over, so then it's going to be our an, which is going to be minus 1 to the n times n cubed over 3 to the n. And the absolute value of all of that, so it's going to need quite a lot of tidying up. So that is going to be the lim as n approaches infinity of, well, minus 1 to the n plus 1 can be written as minus 1 times minus 1 to the n. So it's going to be minus 1 times minus 1 to the n times the n plus 1 cubed over, and the 3 to the n plus 1, we're going to call that 3 times 3 to the n. So 3 times 3 to the n. And then we are dividing by the an term, so we're going to multiply by its reciprocal. So we're going to multiply it by 3 to the n over, so we're going to have a minus 1 to the n multiplied by n cubed. And don't forget, we need the absolute value of all of that. So it's going to be a lot nicer very soon. So we can do some nice cancelling. We can take this minus 1 to the n with this minus 1 to the n. We can take a 3 to the n with another 3 to the n. So then we have, on the top, we have a minus 1 and a 3. So they can come out as multipliers, but because they're coming out of an absolute value thing, then that sign of the minus 1 doesn't matter, because once we took the absolute value of it, it wouldn't be negative anyway. And then we're going to just have n plus 1 cubed over n cubed. So we can now say, well, this is 1/3 times the lim as n approaches infinity of the absolute value of n plus 1 cubed over n cubed. So if you've got one thing cubed over another thing cubed, then you can put them together. So equals 1/3 times the lim as n approaches infinity of the absolute value of n plus 1 over n. All of that cubed. So if we carry on working on this, we can say this is 1/3 times the lim as n approaches infinity of, well, it's going to be n over n plus 1 over n. So n over n is 1 plus 1 over n, and then we cube it. So as n approaches infinity, 1 over n approaches 0. So the bit in the absolute value part is just going to be 1 plus 0. So it's now 1/3 times, well, the absolute value of 1 plus 0 cubed. So it's just 1/3 times 1 cubed, which equals 1/3. So if we go all the way back up, what does this tell us? So we have just found the limit as n approaches infinity of the absolute value of the ratio of the next term of the sequence over the current term of the sequence. And we have shown that it's less than 1 because it is 1/3. So that tells us that the series, this particular series here, AN, is absolutely convergent. The series from n equals 1 to infinity of -1 to the n times n cubed over 3 to the n. So this is absolutely convergent. And the reason for that is the ratio test.